everyone. I hope all of you are doing well. And here we are at the final session of our IoT course. This session, we're gonna separate it into half. I know that this list is gonna be a project overview, but we are gonna have two sessions, so in two parts of the session. الجزء الأول من السيشن حنراجع اللي أخذناه. So it's gonna be like an overview for the course وحناخد فيه a small quiz. Okay. وبعدين we're gonna go into the project overview. Okay. هناخد break in the middle between the two parts of the session. So here we are. So now we started from an intro to IoT at session 1, and today we are at the final overview for the course. طيب going into the review for the session مراجعة. قلنا إنه if you want to build an IoT system, you have to make sure that your system has two capabilities. One of them is internet connectivity and computational capability. في الجزء الأول من الكورس ركزنا على الجزء بتاع computational capability. Just 1 second, شوي في إزعاج. 1 second, خليني make sure that this goes away. Okay, going back. So الجزء الأول إنه تكلمنا كيف how do we equip our systems with computational capability. تكلمنا على different types of microcontrollers, الكاركترستكس اللي على أساسها نختار المايكروكنترولرز. واللاست سيشن كانت mainly على النتوركينج والكونكتيفيتي. طيب with IoT systems ممكن we can measure different type of signals. If we are using the right sensor for that, يعني إذا مستعملين السنسور المناسب ممكن نقيس temperature, whatever voice level, sound level, voltage. Okay. يعني ال Internet of Things system can be coupled with any type of sensors, any type of actuators. السنسورز هي الجهاز اللي يقيس ال physical phenomena, okay. وعلى أساسها our microcontroller makes some computations ويطلع output للأكشويتر المعين, okay. الأكشويتر it could be as simple as an LED مثلا زي ما شايفين هنا مثلا, okay. An LED just signs a light إنه مثلا something happened or something did not happen, or مثلا يفتح الباب, okay. This is one could be a type of an actuation. This is an ultrasonic sensor. حنعمل تجربة بسيطة مع الالتراسونيك sensor في الجزء بتاع البروجكت, okay. طيب تكلمنا عن how do we choose the right microcontroller for our project. مثلا from a simple microcontroller like an Arduino Uno or a more sophisticated one like a Raspberry Pi اللي هو يعتبر a single board computer. عرفنا مثلا different type of microcontrollers, ايش الكابابيلتي او الكاركترستيك على اساسها نختار المايكروكنترولر, البيت ويدث, البرفورمانس, الكلوك تايم, الباور ريكوايرمنتس حقت المايكروكنترولر, اوكي. في جزء مهم تكلمنا برضو عنه كان اللانجوج اللي that we're gonna use to program the microcontroller. Mainly now we have C or Python, okay. Python is a high level language. It's an interpreted language وأسهل for us as users in نكتب Python rather than C, okay. But C is a compiled language, is a lower level than Python, more closer to the machine, okay. طيب طيب إذا هي Python أسهل ليش الناس يستعملوا C? Why do we see more? Although Python أسهل بس C is seen more in IoT systems. Why? Because C is, we can control our microcontroller more. We have more control in the operation, okay. C-based microcontrollers are faster, and we can make the requirements for real-time applications. We can satisfy that more with C systems, okay. فعشان كده C is seen more in especially IoT اللي هي industrial IoT. فممكن نقول إنه مثلا Python you can use it for مثلا stuff that does not need critical real-time applications. أصلا Raspberry Pi it was mainly developed, Raspberry and Arduino كلهم developed for educational purposes, okay. It's okay to learn the IoT and the programming in Python, but if your application ended up needing critical real-time requirements, then you might want to go for C. Um, Again, you're gonna see this a lot. If you're gonna join this as a job or you're gonna be in the IoT market, هتشوف دايما حيكون في this choice between C and Python. Okay. طيب. آخر حاجة تكلمنا عن ال connectivity. Okay. In the connectivity, just one second, guys. Sorry. In the connectivity or the networking lecture, we talked about how do we connect our IoT devices to gateways. طيب خلاص احنا خلصنا. Now they are equipped with the right sensors, with the right actuators, with the right microcontrollers. طيب اللي هي requirement تانية من ال IoT system is the networking part or the connectivity to the internet. We don't directly connect to the internet. We have to have middle gateways that are close in proximity، يعني قريبين من السنسرز، لأنه ما عايزين السنسر تضطر ترسل لمسافات بعيدة. ليش؟ mainly for the power requirements، لأنه ال IoT systems are mainly يعني power restricted. ف دائما يكون المايكرو كنترولر فيه light weight networking protocol، ما يحتاج لباور كثيرة، والداتا ريت حقه low، يرسل الداتا اللي عنده ل nearby gateway. بعدين this gateway can do some مثلا if we are operating in a fog computing kind of regime، يعني تعمل عليه شوية computations on the edge on this gateway, and then more comprehensive computations are done on the cloud. Okay, the gateway is connected to the cloud via an IP protocol, the standard internet. Okay, and all those networking protocols that I'm talking about here are from the IoT device to the gateway. Again, we talked about the paradigm of power versus data rate versus range. Usually IoT devices have low power capabilities, then they operate in low data rate and relatively low range, but some of them have high range. We talked about the different protocols that are available, and we focus on LoRaWAN mainly. It has different, and it is more powerful. It has more like powerful characteristics compared to all the other listed protocols. The last slide, I think, on the networking lecture was about what would be the benefit if our IoT devices were directly accessible from the browser. يعني if our IoT device was like a computer that has an IP address and I can directly ping my IoT device, wouldn't that be great? So you can directly access from any just web page or anything. You can ping it, you can do anything to it remotely. You don't have to go through the gateway. So like right now, in most of the IoT systems, you have the gateway in the middle between the cloud and the IoT device. Challenges with that is to implement the IP protocol in the IoT devices. It's heavyweight. It's gonna like increase the requirements in terms of the memory, etc., on the IoT device. I think that would be an overall overview of what we have covered so far. My advice, if you are building an IoT system from scratch، أول حاجة تعرف إيش what do you want to measure exactly. The last thing you want to do إنك تختار sensor that does not reflect what you want to measure. Okay. Make sure إنه sensitivity حقت السنسر gives you the right type of information. إذا أنت الابلكيشن حقك very sensitive ومحتاج مثلا data in milliseconds or in millivolts بتفرق معك، لا اختار sensor يكون يعني يعطيك the right type of sensitivity. Also, sensitivity is affected by the analog to digital conversion. If you want a sensitive measurement, make sure that you have an ADC with lots of levels, okay? So that the smallest change in the sensor value is reflected on the ADC output, okay? Also المايكرو make sure you choose the right of microcontroller إذا البروجرام حقك is heavy that require lots of computations done in the microcontroller. فاختار microcontroller يكون الميموري حقته أو الرام حقته is comparable to your computational requirements. Finally, how are you going to connect your what's your power situation basically? Okay, إذا أنت مثلا ال IoT system حقك is plugged يعني if this IoT system for example is in a fixed device, it's not إذا مثلا هيتركب في ثلاجة أو في مكيف or something that already has power plugged in, so you don't have to worry about power, right? So in this case ما لازم you don't have to go for LoRaWAN or all those low power protocols that we talked about. You can simply have a Wi-Fi. Wi-Fi is power hungry but very versatile and reliable. Okay, يعني إذا ما عندك مشكلة حق power, you can go for Wi-Fi as a connection between your IoT device and the gateway. Okay, إذا لا عندك power requirements, you cannot use Wi-Fi, then you go for the low power protocols like for example Bluetooth Low Energy, Zigbee, or LoRaWAN. As I said, LoRaWAN is suitable for when you have low data rate requirements and high range. Okay, يعني مثلا if in an agricultural type of project the sensors are scattered all around والgateways بعيدة منهم, فLoRaWAN is good in this case. بس إذا السنس يعني أنت you're dealing with the home settings where the sensors are like few meters away, you can use Bluetooth Low Energy or Zigbee in this case. تمام. يعني there is no one size fits all for IoT. It's all about your application and your requirements. وقلنا you want to be cheap, okay? You want to be يعني توفر في أي حاجة ممكن تعملها عشان ال IoT is deployment حقته is not just one IoT sensor, صح؟ يعني you want to deploy it in a wide range, $1 or $0.50 بيفرق في ال IoT deployments. We always want to get the stuff that just will do the job for us. ما عايزين نكون wow, so if 1 megabyte of RAM will do the job, then I'm not going to get 2 just in case. We don't have those type of things for IoT. طيب, do we have any questions before I start the quiz? I think we are ready for the quiz now. Yeah. So do you have questions? أي أسئلة؟ Let me see the okay, so are you ready to start the quiz? Okay, just try it and okay, so admins, can you please share the link for the quiz with the participants? So what you have to do is you have to go to this link and you will see a list of questions that you can answer. So for example, here's our first question. When you go to the link, you can input your answer over there. So this is the link, olive.com/mayali536. Okay. Sorry guys. Can you guys see the questions? Are you able to answer? Um, Not sure if we. Um, I can't see the response from the audience. Okay, so we have some answers, and all of them seems to agree on the right answer. So, what's the correct file extension for Python? It's .py. Okay. Second question: what's the correct syntax to output the type of a variable or object in Python? So we have four options. Great. Okay. Print type of X. Okay. The third question is what's the correct syntax to output hello world in Python? Most basic one. Okay, great. How do you create a variable with the numeric value 10? Actually, the second one is also correct. Okay, both of them are correct. The most like widely used one is the first one, but the second one will also give the will do the job as well. Uh, okay, so now this is related to IoT, not to Python. Which of this is not a tier or like of the Internet of Things architecture? It's not like a main layer of IoT, basically. So all the others are layers in IoT except for one of them. What is it? It's a component, but it's not an entire layer by itself. Are you guys sure? Think about it. So we have like three main layers. The first layer, yes, okay. So sensors are part of the devices, okay. So the devices have sensors, have actuators, have whatever, the microcontrollers, the networking component, okay. So sensors is part of the device layer. It's not a tier or a layer of an IoT. Okay. Gateways are connected to cloud servers via which networking protocol? Did we miss a question? Oh, oh no. Yeah. So this, I think we gave an overview. We answered this question in the overview. If in case you missed the last session, gateways are connected to cloud servers via which networking protocol? It's Sigfox, LoRaWAN, IP, or Wi-Fi. A bit tricky, but you guys can do it. Great, yeah. So anything after the gateways is IP. Okay. Sigfox, LoRaWAN, Wi-Fi, all of this goes from the device to the gateway. أي شيء بعد الجيتواي هيكون عبارة عن IP protocol connected to cloud servers via the internet, the standard internet protocol. Okay, great. So people are doing well. You guys have done your homework, I guess, in revising. طيب تمام هناخد break just to do the project setup, project demo setup, and I'll see you I think in 10 minutes. Now it's 12:20. I'll see you at 12:30, okay? And if you have any questions, if you're thinking about starting your own IoT project, please come back with questions so we can discuss them. Thank you so much, and I'll see you in 10 minutes. Okay, so I guess we should be back by now. Are we on? Okay, great. So the second part of the project, I wanted to share with you part of the research I'm doing that's related to IoT. Okay, so let's do that. So first, let me share with you. I'm gonna share a new screen. Okay, so this project was done for a course last fall. Um, which is voice-based emotion recognition remote health monitoring system. So the idea of the project that we wanted to build يعني كنا عايزين نعمل أنا كلمتكم قبل يمكن في المحاضرة الأولى إنه my main research is in remote health monitoring. okay. فعايزين ندي ال RPM system or remote health monitoring system the capability of being emotionally aware. Now the health monitoring systems are being widely deployed مثلا because of the COVID. People who are in isolation are can be remotely monitored من غير ما مثلا يضطروا يجوا for you know follow ups or so. وكمان ال RPM is widely employed for elderly patient monitoring اللي عندهم chronic disease مثلا we can measure their sugar level, blood pressure, heart rate, etc. نوفر عليهم انه لانه اللي هو الروتين تشيكس مع الدكتور ممكن تكون بالنسبه لهم صعبه من ناحيه الحركه اكسترا. فدوز بيبل ممكن يكونوا عايشين لوحدهم، فالناحيه النفسيه بالنسبه لهم كمان مهمه، فلازم نعرف what's going on with them. يعني okay we're sure that they are physically okay, we also need to make sure that they are mentally and emotionally as well. فالسيستم كان الفكرة إنه it's voice based، فبيست من ال patient's voice نقدر نعمل assessment their emotions and mood. فمن غير ما أمشي في الديتيلز حقت السيستم and why do we need أصلا remote patient monitoring all of this, I wanted to share with you the structure of the system. طيب الايموشن assessment by the way ممكن it can be done through various channels وكلها يعني من خلال IoT system. ال IoT where it happens إنه sensor will grab the signal, the physiological signal that we are going to use for the emotion assessment. ممكن تكون من خلال الفويس، ممكن الفيشل اكسبريشن إذا عندنا كاميرا مثلا، من خلال مثلا الفيتال سايز نفسها، الفيتال سايز that we are measuring remotely ممكن نستخدمها عشان to assess the emotions. يعني في ناس عملوا على الهارت ريت، ال EEG، التمبريتشر followed مثلا مع some يعني if we can measure the sweating of the people، مثلا الناس لما يكونوا مثلا nervous they sweat more right، الهارت ريت حقهم يزيد. ف يعني في sensor fusion can be done to measure emotions as well. بس نحن قلنا ال voice is less intrusive، ما لازم نعقد السيستم أكتر. يعني مثلا إذا people are just for COVID ممكن يكون ال monitoring system very simple. We don't need to add extra sensors just for the emotion recognition. فال voice is the simplest way of doing that. The emotions are there myriad of emotions, okay. بس في عندنا simple ones those are the basic, we call them those are the basic emotions. The system that we built are based on this. Okay, so don't need to worry about this. This is just presenting the different physiological signals that we can use for يعني eliciting the emotional level of people. So we're going to use machine learning. يعني after we use the IoT part in extracting the signal اللي هي voice, so we're going to have a speaker that's going to be, for example, in the living room or in the bedroom, wherever the person is, that will grasp the voice signal, and then this will get transferred to a gateway. So we can either do the computation على نفس السبيكر، يعني نحط فيه المايكرو كنترولر inside the speaker, or it can be transferred to a remote gateway and we do the complications. بس the most widely scenario that يعني it's going to happen إنه ال basic computations for the mood assessment are going to be done on the gateway, and then the same information are going to be transferred to the cloud for more cumulated assessments. يعني مثلا we do accumulation for the emotion مثلا over the month ايش كان المود حاصل. If we did some sort of emotion induction اللي هو we try to regulate how the people are feeling. يعني إذا مثلا we sense that someone is sad over few amount of days كان كل الأسسمنت giving us sad the classification that happened. فممكن نعمل emotion induction, we give them more motivational messages. مثلا light conditions, there are also some studies in light conditions can help improve the mood. إذا مثلا الواحد على طول قاعد في غرفة مثلا ظلام وكده, we can through IoT as well control the lights, and we can play some like relaxing music. فالمهم نحاول إنه نحسن المود, و again we test what's happening with the emotions. Did it improve, also calling their loved ones. Let's see what's going on. So this was the scenario for the system architecture. We have a screen that's based on the living room, and it displays some questions. How are you feeling today? How is your day going, etc. And then the person will respond with voice, and then the assessment happens, and then we play the music, or the microcontroller over here can control the lights in the room, or whatever emotion induction that we choose to do. Okay, so this is one of the proposed scenarios for that. The second scenario, this has been done on the first version of the project, this screen type of thing. Right now, we are working on the second iteration where we are using the phone. So the chatbot is deployed inside the phone, okay? And it will intrigue the user with daily questions or multiple questions per day, and then the user will respond with a voice note. The assessment happens over there. So this allows for a more ubiquitous type of monitoring. And I know the phone is always around us. This thing is just in one room, or either it requires to have multiple systems around, which might complicate the design. But if we embody it in the person phone, then we make sure that الفون على طول موجود معاه, so the system is more like compact. Another thing that's like widely deployed, especially with elderly, is the robots. There is a study that showed that elderly people greatly respond to talking robots. ففي هنا especially in Canada في الhomes حقت where people خلاص retirement homes, etc. They use those type of robots to encourage the people to eat properly. Some of them they lose, يعني مع dementia and those things, they lose the ability how to eat properly. So the robot will do something, and the person will try to follow what he's doing. So this can also be deployed on the robot itself. طيب, how are we doing in terms of time? So this is the simple system architecture. So we're going to have the IoT system is going to be over here, where it will grasp the voice signal. We're going to have these computations done over the microcontroller. They're not very like computationally heavy. So a simple microcontroller like an Arduino or the ESP8266 that we use would do the job. So this is a simple machine learning model. CNN, computational or convolution neural network. We're going to do some feature extraction. Okay, I need to note that the features that we are using are not, and when I ask that, when the chatbot or whatever or the robot or whatever asks you, how are you doing today? You said, oh, I'm doing well. We don't care what you said, like well or bad. So the features are not extracted from the word, not from the semantic content of the message, but from the acoustic content. Yani, how are you seeing? Are you seeing it like slowly or fastly? What's the frequency? Are you doing some stuttering? Those type of things. What you say is not important, rather like how you say it. So we're using the acoustic features of the voice signal. After we extract the the acoustic features, then we do which acoustic features are we going to use? Are you going to use the pitch, the tone, the frequency? There are different, like there are a myriad of acoustic features. Then we do extraction, feature classification. So how do we classify those features? And then we make the decision on which emotion does those features represent. Okay, we're gonna see this more when we go to the Colab and see the code. Uh, so on what type of acoustic features do we can use? I don't think we need to go into this, but the most widely used features with voice signals are the male frequency spectrum coefficients, MFCC, and this is what we're going to use for our system. We don't know how. So this is like this, like how of the MFCC are formed. We use FFT, fast Fourier transform. Then we do use triangular filters, etc. So some signal processing going on. So those are the emotional models. How do we classify emotions? So we have something called arousal and valence. Um, Valence means the emotion is positive, okay? Arousal means how strong the emotion is, okay? So if an emotion have high valence and high arousal, that means it's a strong positive emotion, versus if an emotion, for example, have low valence but high arousal, that means it's a strong negative emotion, etc. Okay, so wherever the any emotion we detect, where we see where does it feel fit in this two-dimensional plane, and then accordingly classify the emotion. The basics of machine learning, we have to use the appropriate model for our problem. Um, we use the CNN, and a simple CNN, not very complicated one. Those are the basic emotions that we said. They call them Ekman emotions. Ekman, he's a famous psychologist. The model also has neutral, I guess, in it. There's a neutral. So if someone might not have any feelings, right? I'm just okay. I'm not happy. I'm not sad. So neutral is also included over there. Okay, so the data set we're going to use, it's the Ryerson University Audio and Visual Dataset. It's it's quite a quiz. Ryerson is another university in Toronto, by the way, and I study at the University of Toronto. So, and the University of Toronto have their own voice-based dataset. So I should have probably looked into that. So let me share with you how does the RAVDIS dataset look like. Let me stop sharing this and then go to the RAVDIS. Entire screen, Chrome tab. Yeah, this one. Okay. Can you see it now? Yes. Okay. You can. Okay. So this is the data set that we are going to use to test our machine learning model. So this has nothing to do with IoT. Okay, but IoT is never used alone, right? So we don't use so what IoT does is just it grabs the signal, and then you have to do some computation on it, right? We have never discussed or maybe you have just presented small briefs or snippets of code for making the LED lights or those sort of things, but usually the IoT is used with more complex scenarios like this one, and machine learning is often involved. So I'm going to use the RAFTES dataset, which has audio files for actors speaking, displaying different emotions. Okay. Let me just make sure that people are following what I'm saying. Okay, so speakers were like speaking happily, sadly, neutrally, so let me. Okay, so I want you to look how are the files named, because when we use the model, I want you to know what emotions are we checking. The modality, whether it's a voice or video or audio, we're just using audio because we don't need the video files. We're checking the emotions from the person's voice. Okay. If we had the capability to have a camera on all the time, then we could use the facial features joined with voice to see to do like some sort of sensor fusion type of thing. The vocal channel edits speech or song. So we're using speech now. Emotion. So we have neutral, calm, happy, sad, angry, fearful, disgust, and surprise. So we have like 8 emotions. The intensity, is it normal or strong? So all the other all emotions have normal or strong, except for neutral. You cannot be strongly or normally neutral. Statement. So all the statements that are uh, played on this dataset, just two statements. Kids are talking by the door or dogs are sitting by the door. So all you're gonna hear from the actors are those two statements. They have nothing to do with how people feel, right? But still, because we are not checking how people feel from the what they're saying, rather how they say it, we can still like detect that repetition, whether they're repeating it or not. And then the actor, we have 24 actors, I think half male, half female. So from the video name, you can check what's happening there. So mainly we want to look for 1, 2, 3, number 6. So number 6 will tell us what's the emotion that's played in this audio file. So 6 means that this is fearful. Okay. So if our model detected fearful, then we are okay. We got the right emotion. So I'm just using this data set to train my model, my machine learning model, but later on I'm going to use the model. I'm not going to have to tell the people to just say kids are talking by the door or dogs are playing by the door or whatever those two sentences are. People will just respond with whatever speech they want, and I still can detect what they're saying. Why? Because I did not base my model on the sentences or the words of the sentence, but later on the acoustics of the actors, right? So whatever the people are saying does not matter. Okay. Uh, so someone might ask, okay, if you're saying that this model does not depend on the word said, but later on the acoustics, so can I play this model on speech that's not English? Can I play it in Arabic? So I did not test it, but I'm assuming that it's not going to work because the acoustics were like the way we speak Arabic is not the same. So the sounds, the مخارج الحروف, those type of things are not the same. So it might not work properly with Arabic, but someone might want to try it out. So I'm willing to share the model, and if someone wants to be base this on an Arabic type of audio files, it would be great. Please let me know what happens. Okay. And also, this might be a good time to advertise our current study. If someone is willing to be kind enough to be a participant in our gathering of our own data. So we build a model that works on the RAPDIS dataset, but we want to build our own dataset. So if you agree to be a participant, please contact the admins, and then they will link me to you. We will send you daily questions for which you have to respond in English, and then we will gather this data set and then run our model again on the gather this and see the performance difference from the standard data set that's done by actors versus the data set that's based on like normal people, speech. Okay, that being said, now we're ready to go to the model. So we know what we're going to train our model on. Let me share the model page. So I'm gonna stop sharing the screen and share the Colab page. Chrome tab, yeah. Okay, so this is our model. So it's Python. Yeah, you can guess that, right? I'm a Python person. Okay, so first, I hope you know Colab. If you're not, you should. Okay, and it can make your life much easier. So I could have done this on standard Python like that we saw earlier. But Colab make collaboration easier. If I have other people working with me on the project, we can write the code together, do some different run times. I don't have to worry about my laptop having the required space. So you can see that I'm using, um, I have 65 gigabytes available for me to run my computations on, and I cannot dream of having that on my own laptop. Okay, so this is great. This is on the standard free version. Imagine if you have a paid account, then you can have some GPUs to run your code on. Um, okay, so first I am going to import the libraries that I need. So Librosa is a Python library for dealing with voice files. Okay, I'm going to use Librosa to extract the audio files that I told you. Okay, TensorFlow is also a library for dealing with neural network. I believe the Sudan chapter, they had a TensorFlow workshop or so. Okay, so it's by 5. I'm doing this. This is also for audio files, um, because I said I'm not. So now I'm running it from my laptop, right? But all of this is going to be employed on the speaker or that small screen that I'm going to be putting onto the person's living room or inside the phone. Okay, so I need this to deal with the audio files. Okay, so this is my model. This is my machine learning model. So let me upload my model. It's right here, should be right here, model.h5, right? So this is how it looks like. um, this is like a summary of my model. It's a convolutional neural network. It has total parameters of 2872. So if, if you, okay, we don't have time to to give how does neural network works, but basically the parameters of the neural network are how do I control the output of the neural network. Okay, so first I can initialize all the parameters to be 0.1, and then I'll do a first pass of the network. I'll give it an input and see how does the output look like. Probably it's going to be very bad and does not represent what I want. Then I will go back and change, do a backward propagation and change all the parameters based on how wrong the output is. Okay, again I'll do a forward pass. Probably the output is going to improve a little bit, but still I'm not satisfied. Do a backward pass, change the parameters, you know, until the output satisfies the accuracy level that I want, or the change in the parameters is not significant. So like I'm changing, but it's not like I'm changing like in a step of 0.001, then خلاص, I'm gonna stop changing it, and this is my final model. So I have like how many layers? So you can, so 1, 2, 3, 4. It's a 5 layers, or 6 layers, I guess. Okay, 6-layer neural network. I don't want to play this. Okay, so I want to install the libraries needed for the voice, how to deal with voice files. Okay, I can either record a sound or upload one of the files that I told you about, right? So this is a file that has emotion number 5. What was emotion number 5? It was, I guess, let me check. Emotion number 5 was angry. Sadly, it's angry. Okay, or I can play my own voice. Okay. Hello. So, hello. Well, let me see if it has been recorded. Should be. What's that? So now I would like to extract the feature. So let me see what's happening here. A is not defined. Okay, so you guys cannot hear what the voices that's being played, right? Hello, hello. Okay, let me upload the voice sample just in case, so we could, make sure that you hear it. Sorry about that. The time is really not in our okay. Audio. So we might take some time, but okay. So I'm gonna comment this, and so one of them is for you inputting your own voice, and the second one is for testing the system with one of the voice samples. So what I did here is I uploaded three, actor number 30105. I think it's the right one, except the last one is one, so I'm just changing this. So this should do the job. Okay, so this is how the sound looks like. Let me see if I can play it for you guys. 05. Okay.
Kids are talking by the door.
Can you guys listen to that?
Kids are talking by the door.
Were you guys able to hear the sound? Let me just put on my. So it sounds angry, right? So let's see if our model is going to detect this as an anger input. Okay. So let's just play it one more time before going back to our
Kids
model.
are talking by the door.
Okay. No voice. Sadly, there's no voice. I'm not sure. There's an option to share like voice or something, video files. No, there's no option for me to share the voice from here. But the voice that I played was for an angry like audio. You can share as a tab. Okay, share as a tab. Okay. This one, okay. So now I shared it as a tab.
Kids are talking by the door.
Did you hear it now? Okay, so that was the audio signal that I'm going to use for testing the system. So let me go back to sharing the Chrome tab. Okay, so this is the this is the acoustics. Are we going to use all of this range? No, this is way too many features that we need. So now we're going to extract the features that are important for us. Okay. I did not play this because this where I can record my voice, and now I want to test it with that audio sample. Okay, here where I'm going to extract, I'm using the Librosa library to extract the MFCC features. So Python has MFCC as a function, Probably if I'm going to do this in C, it requires me a bit of code write up. So something is going on with MFCC. Not sure why. ACFE. What's the array dimensions? 40. And what's the output? Where is the model? It's 40 as well. So this should be okay. So I have 40. Those are my features. 40 features, and it is not right. So here I'm trying to extract the features and then based on that predict the right emotion. I should have 40 MFCC features because those are the input to my the face layer over here. Okay? So I should extract 40 of them, and then I'm extending this to another 64. The second layer is going to have 64 like neurons. Let me see what's happening here. And the output should have like the different type of emotions that we discussed earlier. Okay. 1 second, let me just stop sharing and open another file. Yeah, this always has to happen when you're testing a machine learning model. Don't worry, guys. No pressure. So that we're taking longer than expected. Not entirely sure why is it doing this. Okay, drive.
Hello, hello.
Sorry. So this one has its built-in. Hopefully this will work. Mm. Um, So the not nice thing about Colab is that, so it's a runtime, right? So they're not gonna save your progress. So you do something, you go away, then it's just you have to do it all over again, and those files also have to be uploaded each time you're gonna do the runtime. So I'm not recording. I'm doing this right now. So this is my last file. Let's go for some reason.
Kids are talking by the door.
So this one has the issue. At this stage, I really don't know what's happening, but just to fast forward what's supposed to happen. The So those are the different emotions that we are supposed to get, and the model should display the right. It would display like a visual image of the emotion. For example, here this is angry, so we should have seen this type of image when we detect this. So this is not going to be displayed to the user. Okay, so if we detected that the user is angry, we're not going to tell him that we detected you are angry, but rather we are going to do the emotion induction that we talked about, either like how do we do with angry people, like calming messages, etc. Okay. So it's telling me here that the issue is with the MFCC extraction. Not sure why, but probably some sort of bug, or someone has played around with the model from the last time I checked, because it's shared with my other partners. Okay, the other thing I wanted to do is with the ultrasonic sensor. Well, I don't think we have the time to do the demo. But probably I could hold office hours or so for projects. So I know that some of you have contacted me over LinkedIn that they have their own projects that they want like the specifics about them. So probably I could do that, hold an office hour over Zoom or so. I'm not sure how can I could discuss this with the admins um, to arrange it. So the people who are working on specific projects can come, and then I could bring the other sensor and do it. Sorry that this doesn't work, but this is like the overall flow of things. Okay, so the IoT, now the IoT doesn't look like the main focus anymore, right? So it's just used as a mean to grab the signal, and most of the work is done over the computational part of it, and this is usually how things are done. So if I can open just the camera for a little while. So this is the grab the voice. Okay, so it's like right here. So if it's and after that we the microcontrollers, we can like hook it under the speaker. Yeah. So yeah, it's just could be Alexa. You could use Alexa. You could use wherever, or if you're using it over the phone, you can just use the phone speakers. Okay. So I think that's it for now. And thank you so much. I know that there are not many of you around, but you can. Okay. So Muhammad. So thank you, Muhammad. Thank you, Maram, for being around all this time. Thank you with the GDSC, UFK, University of Sohar, and all the other, and Mina. So everyone who has helped this course, facilitated the delivery and all of that. Thank you so much. I'm happy that I got to know all of you, and I hope all the attendees have benefited from the course. إن شاء الله نشوف مشاريعكم. And you know my LinkedIn. I think يعني most of you know my LinkedIn. In case you don't, I can share it with you. Please send me a message over there if you still have questions. And yeah, I'll be happy to connect with all of you over there as well. And that's it for today. Thank you so much. Okay.